Hello everyone, welcome to our incredible channel, F-Metrics, your learning space for GIS, remote sensing, surveying, and geospatial technology. My name is Faiza Msemo, a GIS and remote sensing expert, and on this channel I share beginner-friendly lessons that helps you understand how geospatial tools are used to solve real-world problems in areas such as agriculture, environmental management, urban planning, water resources, disaster risk management, and many other fields. In today's lesson, we are going to answer one of the most important beginner questions: what is GIS? So, by the end of this video, you will understand the basic meaning of GIS, why location matters, the five main components of GIS, what GIS can do, where GIS is applied, and the basic workflow followed in GIS project. Let us begin by understanding what GIS really means. GIS stands for Geographic Information System. In simple terms, GIS is a computer-based platform used for collecting, storing, managing, analyzing, and visualizing location-based data. This means GIS helps us with information that is connected to a specific place on the Earth's surface. For example, GIS can help answer the question, what is Earth? This may involve locating a school, hospital, roads, river, farm, water point, or settlement on a map. GIS can also help answer what is nearby. For instance, we can identify which villages are close to health facilities, or which farms are near water sources, or which buildings are located within a flood-prone area. Another important question GIS can answer is what is changing. GIS allows us to track patterns over time, such as urban expansion, forest loss, water level changes, land use changes, or crop condition. The main idea is simple. When we combine location, data, and analysis, we can make better decisions. So GIS is not just about producing maps, it is a system for turning location-based data into useful information. Why location matters? Location matters because most data becomes more meaningful when we know where it is. A list of hospitals, for example, it is useful, but if we place those hospitals on a map and compare them with roads, population center, and settlement areas, the same list becomes much more powerful. With GIS, we can see which communities are well served, which areas have poor access, and where new facilities may be needed. GIS allows us plan services more effectively. For example, government and organization can use GIS to decide where to place hospitals, schools, water points, markets, or emergency response centers. It also helps us understand spatial patterns that may not be visible in a normal table. These patterns may include hotspots, areas with high agricultural potential. In other words, GIS connect raw data to real-world places. This connection help decision makers understand context, compare locations, and make better choices. That is why location is one of the most important elements in planning, management, and development. The five components of GIS. GIS is more than a software. It is an integrated system made up of five main components. The first component is hardware. This includes the physical equipment used in GIS, such as computers, GPS devices, drones, mobile field devices, servers, and other data collection tools. The second component is software. These are programs and platforms used to process, analyze, and visualize spatial data. For example, QGIS, ArcGIS, Google Earth Engine, Google Earth Pro, Colab, and other mapping platforms. The third component is data. Data is the foundation of every GIS project. It may include maps, satellite images, roads, rivers, buildings, population data, elevation, rainfall data, soil data, and administrative boundaries. The fourth component is people. GIS depend on skilled users who understand both the tools and the problem being solved. So this may include GIS analysts, surveyors, planners, researchers, engineers, environmental expertise, and decision makers. The fifth component is methods. Methods are the workflow and procedures used to solve spatial problems. These include data collections, data cleaning, spatial analysis, modeling, map design, and reporting. For GIS to produce the reliable results, all five components must work together. good software alone is not enough. We also need good data, proper method, skilled people, and suite of hardware. What can GIS do? Here we are looking more about capabilities of GIS. GIS can do many things beyond creating digital maps. First, GIS is used for mapping and visualization. It helps us convert raw data into a clear and informative maps that are easy to understand. The second, GIS can measure a distance and area. For example, it can calculate the distance from a village to the nearest health facility, the size of a farm, or the total length of a road network. The third, GIS can overlay multiple layers. This is one of the most powerful GIS functions. For example, we can combine rainfall, slope, soil, road, river, and land use layers to identify suitable areas for farming, settlement planning, and water harvesting. Fourth, GIS can analyze patterns. It helps us identify relationships and trends across the space, such as where flood occurs most frequently, where population is concentrated, or where the land use is changing. The fifth component, GIS can monitor change over time. It can be used to track urban growth, forest cover change, drought condition, crop performance, or even changes in water bodies. Finally, GIS can help find suitable locations. This is useful for selecting sites for schools, hospitals, warehouse, education schools, conservation areas, or infrastructure projects. So GIS is not only about a mapping tool, it is an analytical engine for understanding world spatially. A real-world application of GIS. GIS is widely used across many sectors. In agriculture, GIS supports crop monitoring, farm mapping, soil analysis, and irrigation planning. It helps farmers, researchers, and planners understand where resources are needed and how land use can be managed efficiently. In urban planning, GIS is used for road planning, land use zoning, settlement mapping, drainage planning, even infrastructure development. So in environmental management, GIS help us monitor forest cover, wetland, protected areas, and land degradation, pollutions, and conservation zones. In disaster management, GIS is used to map flood risk zones, drought-prone areas, landslide hazards, evacuation routes, even emergency response locations. In water resources, GIS supports watershed analysis, groundwater planning, river basins management, water supply planning, and rainwater harvesting studies. In transport and business, GIS help us with the route optimization, delivery management, market analysis, site selection for shops, factory, warehouse, even service centers. So these are just some of examples that show that GIS is practical. It supports better planning, better monitoring, and better decision making in many real-world situations. Basic GIS workflow. Every GIS project follows a structured workflow. The first step is to identify or to define the problem. Before using any GIS tool, we must understand the question we want to answer. For example, we should where should we build a new water point? This is one of the important questions as a GIS expert you have to ask yourself. And once you answer this kind of question, you'll be able to identify or to define the problem. Another question is which areas are at risk of flooding? Which communities have poor access to service? So once you answer this question, you'll be able to identify the problem or define the problem. So once you identify the problem, the second step is to collect the data. This may include GPS point, satellite images, field survey data, road network, rainfall data, elevation data, population data, or even administrative boundaries. The third step is to prepare and clean the data. This involves checking for errors, organizing dataset, setting the correct coordinate system, and make sure that all the layers are ready for analysis. The fourth step is to analyze the data. This may include measuring distance, overlaying layers, classifying areas, identifying patterns, modeling risk, or selecting suitable location. The fifth step is creating maps and reports. The result must be presented clearly using maps, charts, table, dashboards, and written explanation. It means just a technical report. The final step is to support decision making. The purpose of GIS is just to create maps. It's not just about that, but to provide useful information that helps our people make better decisions. So, the key takeaway is this. GIS connects data to location, reveal our spatial patterns and relationships, and support evidence-based planning. So, in the next lesson, we'll look at one of the most important concepts for beginners, remote sensing. Thank you for watching and for listening. Don't forget to subscribe, to like, and to leave the comments. See you on the next lesson.